Welcome to our channel. Today we're diving into the heart of our solar system to uncover some truly surprising facts about the sun. You know, that giant ball of plasma that keeps us all alive? It's easy to take the sun for granted, but there's so much more to it than meets the eye. You might be surprised to learn that the sun isn't actually yellow. The light that the sun emits is actually white. So why does it look yellow to us here on Earth? It's all thanks to our atmosphere. Our atmosphere acts like a giant prism, scattering the shorter wavelengths of light, like blue and violet, more effectively than the longer wavelengths like yellow and red. That's why the sky appears blue during the day. At sunrise and sunset, the sunlight has to travel through more of the Earth's atmosphere, leading to even more scattering of the blue light. This is why we often see those brilliant orange and red hues at the beginning and end of each day. Let's talk about size for a moment. The sun is absolutely enormous, containing roughly 99.86% of all the mass in our entire solar system. Because of its immense size, the sun exerts a powerful gravitational pull, keeping all the planets in our solar system locked in orbit around it. It's like the anchor of our little cosmic neighborhood. To give you a sense of scale, imagine shrinking the sun down to the size of a basketball. On that scale, the Earth would be about the size of a peppercorn, orbiting the basketball sun from about 25 meters away. Now let's journey to the sun's core, where things get really interesting. The core is like a giant nuclear fusion reactor, operating at mind-boggling temperatures of around 15 million degrees Celsius. Inside the core, hydrogen atoms are constantly colliding with each other at incredible speeds due to the intense pressure and heat. These collisions fuse the hydrogen atoms together, creating helium and releasing a tremendous amount of energy in the process. This process is called nuclear fusion, and it's what powers the sun. The light and heat we feel from the sun, the very energy that sustains life on Earth, is a byproduct of these incredible nuclear reactions happening millions of miles away. Chapter 4. A star in its prime. Like all stars, the sun has a life cycle. Scientists estimate that the sun is currently about 4.6 billion years old, roughly halfway through its main sequence lifespan. During this main sequence phase, the sun continues to fuse hydrogen into helium in its core, providing a stable source of energy. But as the sun ages, it gradually consumes the hydrogen fuel in its core. Eventually, billions of years from now, the sun will run out of hydrogen fuel in its core. When that happens, it will begin to fuse helium into heavier elements, causing it to expand dramatically and become what's known as a red giant. Magnetic personality. The sun isn't just a giant ball of fire, it's also a giant magnet. It possesses a powerful and complex magnetic field that extends far beyond its visible surface. This magnetic field is responsible for some of the sun's most fascinating and dramatic features, including sunspots and solar flares. Sunspots appear as dark patches on the sun's surface and are cooler than the surrounding areas. They form in regions where the magnetic field is particularly strong, inhibiting the flow of heat from the sun's interior. Solar flares are sudden bursts of energy and radiation that erupt from the sun's surface, occurring when magnetic field lines snap, releasing tremendous amounts of energy. Chapter 6. Catching a sunbeam. It takes about 8 minutes and 20 seconds for sunlight to travel the 93 million miles from the sun to Earth. That means when you look up at the sun, and remember, never look directly at the sun without proper eye protection, you're actually seeing it as it was 8 minutes and 20 seconds in the past. You're essentially looking back in time. This delay is due to the finite speed of light, which is about 186,282 miles per second. While this may seem incredibly fast, the vast distances involved in space mean that even light takes a significant amount of time to travel from one place to another. We touched on this earlier, but let's delve a little deeper into the sun's future. As the sun continues to age and consume its hydrogen fuel, it will eventually reach a point where it can no longer sustain its current size. When the hydrogen in its core is depleted, the sun will begin to fuse helium into heavier elements. This process releases even more energy, causing the sun to expand dramatically. It will swell up to become a red giant, engulfing the orbits of Mercury, Venus, and possibly even Earth. Don't worry though, this won't happen for billions of years. Chapter 8. a gaseous giant. You might picture the sun as a solid ball of fire, but that's not entirely accurate. The sun is actually a giant ball of gas and plasma, held together by its own immense gravity. Plasma is often referred to as the fourth state of matter, after solid, liquid, and gas. It's a superheated state where atoms are stripped of their electrons, creating a sea of electrically charged particles. The sun's surface, which we see from Earth, is called the photosphere, a turbulent layer of plasma that's constantly churning and bubbling. Chapter 9. The Solar Wind. The sun may seem calm and serene from our vantage point on Earth, but it's actually a very active and dynamic star. One of its most fascinating features is the solar wind, a constant stream of charged particles that flows outward from the sun in all directions. This solar wind is made up of mostly electrons and protons, traveling at speeds of up to 1,000,000 miles per hour. It can have a significant impact on Earth, interacting with our planet's magnetic field and atmosphere. The most spectacular example of this interaction is the Aurora Borealis and Aurora Australis, also known as the Northern and Southern Lights. Chapter 10. An Energy Powerhouse. The sun is an absolute powerhouse of energy. It produces an unfathomable amount of energy every single second, equivalent to the energy released by hundreds of billions of nuclear bombs exploding simultaneously. Just a tiny fraction of this energy actually reaches Earth, but it's enough to power all life on our planet. Every plant that grows, every animal that moves, every breath you take, is ultimately powered by the energy of the sun. It's the ultimate source of energy for our planet. Outro. Thank you, sun. Thanks for watching. If you enjoyed learning these surprising facts about the sun, make sure to like, subscribe, and hit the bell icon for more fascinating content. And the next time you feel the warmth of the sun on your face, take a moment to appreciate this incredible star that makes life on Earth possible.